Welcome to Study Loop.
Hello. In this question, we are given information about one of the reactants, and we want to determine information about one of the products. Therefore, this is going to be a stoichiometry problem. And for any stoichiometry problem, the first thing we need is a balanced equation. So let's go ahead and put our balanced equation together. You're told that fluorine gas reacts with water vapor. So that's going to be H2O, which is also in its gaseous state. We're told that this produces hydrogen fluoride gas, or hydrogen fluorine gas, and oxygen, which of course is also a gas. All right, so we need to balance this. I am actually, just because I've already kind of gone through this with trial and error, I'm going to start with the oxygen. There's one oxygen on the reactant side, and there are two on the product side. So I need a 2 in front of H2O to give me 2 oxygen. Now I have 2 times 2, or 4 hydrogen, which necessitates a 4 in front of HF. That gives me 4 fluorine, so I need a 2 in front of the fluorine gas to give me 2 times 2, which is 4. Okay, so we now have a balanced equation, and we want to know what volume of HF is going to be formed. So volume, it's going to be in liters because our other one is in liters. If 3.7 liters of fluorine is consumed. So we've used up 3.7 liters of the fluorine, and we want to know how many liters of the hydrogen fluorine gas. All right, well, we need to assume that the reactants and products are all at the same temperature and pressure. And if that's the case, then the mole volume we typically get from the coefficients in the balanced equation. 2 moles of fluorine react with 2 moles of H2O to produce 4 moles of HF and 1 mole of O2. Well, not only is this the mole ratio, but if we have gases for our reactants and products, and they're all at the same temperature and pressure, this is also the volume ratio. So that's going to be more useful for us. In other words, 2 liters of fluorine gas react with 2 liters of water vapor, and they're going to produce 4 liters of the hydrogen fluorine and 1 liter of oxygen gas. All right, so we can use this volume ratio between fluorine and hydrogen fluorine to solve this problem. So let's go ahead and set this up. We have 3.7, we are given 3.7 liters of the F2. And the ratio that these react in, for every 2 liters of F2, we can produce 4 liters of the HF. So again, we are using the coefficients as a volume ratio, and that works when they are gases and they're at the same temperature and pressure. So liters of fluorine will cancel. To solve this, I need to take 3.7 times 4 and divide by 2. That is going to give me 7.4 liters of the HF being produced. So 7.4 liters is our answer. And our original measurement was to 2 significant figures. So I reported our answer also to 2 significant figures. All right, thank you so much for asking your question, and I hope this was helpful.